Hello, my name is Min Song. Thanks for checking out our blog. We hope you enjoy our video.
Hi there, my name is Stacy Okai. We're both electrical engineering students here at Christian Brothers University, and we're going to talk about our senior project, data logging for Go Baby Go. So, Min, what's Go Baby Go?
Go Baby Go is a program founded by Dr. Cole Galloway that was started in 2012 at the University of Delaware. Go Baby Go aims to provide young children with limited mobility with a means to engage in everyday activities within society. This is done by supplying the children with motorized ride-on cars, or MROCs. MROCs are basically electric toy vehicles that are modified for children with limited mobility. They're an alternative to purchasing expensive motorized chairs that many families are unable to afford. The cars are modified to reduce acceleration, and they also have customized seating to accommodate the specific needs of each child.
Yes, the Go Baby Go Foundation aims to remove barriers for children with disabilities while improving the quality of life. The Go Baby Go Foundation and MROCs promote independence, skill development, and socialization. To gain the most information about how children interact with the vehicle, our project involves developing and installing a data logger inside of the MROC as the current customization. The information recorded by the device will benefit further research.
A data logger is an instrument that monitors and records changes in conditions over time. Accepting analog and digital inputs, the data logger uses a microprocessor, internal memory data storage, and sensors to collect data. A data logger eliminates the need for manual documentation, provides accurate and efficient data, and is inexpensive. Information stored on the SD card can simply be viewed in a text file and opened in Excel for further analysis. For this project, the data logger will keep track of time, date, and the forward and backward motion for every time the MRC is being used. We came up with 3 different solutions, with 2 using an Arduino Uno and 1 using the Nano. After further analysis, we came down to the decision to which model to use for the test circuit.
The first design uses the Arduino Uno and a data logging shield. The shield has a built-in RTC or real-time clock and an SD card holder. Header pins are soldered onto the data logger and simply inserts into the pins on the Arduino for full connection. For testing the device, an LED, a photocell, and a temperature sensor were used to monitor varying data. Some major benefits of the design are that it easily connects to the Arduino, takes up minimal space, and is user-friendly. A disadvantage of the design is the cost of setting up the data logger. All components must be purchased separately, such as the soldering kit, Arduino Uno, and stacking headers. To test the device, an AM2320 sensor was used to measure temperature and humidity, while a photocell was used to monitor light. 5-volt supply power to the Arduino, and a 3-volt coin cell powers the RTC on the data logger. After programming, all data is stored on the SD card.
The second design also uses an Arduino Uno, but this model uses the DS3231 RTC module and an SD card module. The DS3231 also has a built-in RTC, and the SD card module is a separate part from the RTC module. This means that there will be additional wiring for the data logger itself, and I used a DHT11 temperature and humidity sensor to test the data logger. The DS3231 has a built-in power circuit that monitors the status of VCC to detect power failure and automatically switches up to the backup supply. This is so that if the main power supply is cut off, the current time and date will still be maintained. The DS3231 uses a 3.6 lithium coin cell battery, and a major disadvantage of this design is that there's additional wiring and it's difficult to move around. The last design consists of the Arduino Nano kit purchased from the Capteri company. This kit includes the Arduino Nano and a data logging shield that fits into the Nano. The kit also comes with a BMP280 pressure sensor. The sensor is also able to measure the temperature, and this is beneficial because several variables are able to be monitored with minimal components. This shield is similar to the first design, except that it's smaller and it does not need to be soldered.
A big advantage of this design is that this kit comes with all the supplies needed, rather than buying individual parts separately. Components in the kit include a data logger, the Arduino Nano, USB cable, RTC, BMP280 sensor, additional jumper wires, and a micro SD card, all for $29. There are actually no disadvantages for this device. Setting up the circuit, a 3.3 VCC pin provides power to the BMP280 sensor. The BMP280 connects to its respective pins on the Nano to measure pressure and temperature. And as mentioned previously, the RTC is powered by a 3.3 volt coin cell battery. The RTC and SD card are built into the data logger device to keep track of time and store data.
For the total cost of the 3 loggers, the Nano Logger is the cheapest, starting at $46.28. Minus the breadboard and additional wires, the kit includes all the parts needed to build and test the device. In order to test the other data loggers that use the UNO, additional components were purchased separately, which results in the cost nearly doubling for the other 2 designs. Based on the cost analysis and the pros and cons of each logger, we chose to implement the Nano into the current prototype of the car. The Nano is the best option because this design is the least expensive, is feasible with setup taking less than an hour, and it is user-friendly. A test circuit using the Arduino Nano is made up of 2 LED diodes and 2 switches. There are 4 resistors, with 2 being 100 ohms resistors that are in series with the LED. The value of the 100 ohm was chosen based on the LED specifications. The other 2 resistors are 6.8 kilo ohms. They are used as pull-down resistors to eliminate the output from the pin being a floating pin. Because the Arduino has an internal pull-up resistor, utilizing the 6.8 kilo ohm resistors are optional. Using the C++ programming language, the data logger is programmed to record the date and the time when the MRC is in motion. The information is stored on a micro SD card and can be read in a text file. The information can later be transported to Excel for further analysis. There are 4 cases of the switch and LED combinations that simulate the motion of the car. This is a test circuit that simulates the motion of the MROC. Switches are used to turn the LEDs on and off in a simulating motion. One switch is made up of 2 jumper wires that open and close the switch, and the other one uses a push button.
So when the red LED is on and the green LED is off, it prints to the serial monitor that the car is moving forward. When the red LED is off and the green LED is on, it prints to the serial monitor the date and time that the car is moving backwards. If both LEDs are off, just as you see here, it prints to the monitor that the engine is off and the car is not moving. So if we turn the green LED back on and the red LED back on, it prints to the serial monitor that the engine is on and the car is not moving. So the car could be stopped. Now the information is stored to the micro SD card, and you simply take it out of the Nano, put it inside of the adapter, plug it into there, and everything is stored to a text file on the SD card. Alright, so here's our text file, and these are the cases that printed over. This is the column that printed the date, the time, and the case, and you see from here to here it's going forward, from here to there the engine was off and it wasn't moving. Here's the backwards case we had, and here is the other 2 cases where both lights were either on or off and the vehicle wasn't moving. And that concludes our demonstration.
Working on a community-engaged senior project has been a productive and wonderful experience, and allowed us to learn a lot about data logging while contributing to the cause of Go Baby Go. We're grateful for the opportunity to work on this project and to contribute to removing barriers for children in our society. This program affected many lives of families, and we also want to continue to bring awareness to this cause.
Yes, and we would like to thank Dr. Ventura, Patrick McGinnis, Noah Vompit, the group at University Tennessee Health Science Center, including Stephanie Lancaster and Connell Single. We thank everyone for their contribution to our project and encouragement. And this has been an overview of data logging for Go Baby Go.